Push-in connectors, such as Ideal and Shell connectors and Wago push-wire connectors, are highly praised for their ease of installation. Simply push the wire into the connector without any twisting or crimping, making them suitable for both beginners and professionals. Compared to wire nuts, push-in connectors can significantly reduce installation time. Their small size allows for easier cable management in tight spaces, such as junction boxes or behind walls. Push-in connectors provide a secure connection that resists loosening over time. However, they may not be suitable for heavy gauge wires or certain applications where the connector is prone to vibration or movement. Walnuts, such as Wago walnuts and Phoenix contact thin-line compact splice connectors, offer tool-free installation. Unlike traditional wire nuts, they can be installed without any tools, making them extremely convenient. Their compact design saves space, and their transparency allows for easy visual inspection of the connection. Walnuts allow for quick and easy reconnection of wires without the need to cut or remove the connector. They can accommodate a wide range of wire gauges, providing versatility in their application. However, they may not be as secure as traditional wire nuts in certain applications, especially in high vibration environments. Push-in connectors and walnuts are generally easier to install than wire nuts. Push-in connectors offer significant time savings, while walnuts provide a moderate time advantage. Wire nuts are typically considered more secure than push-in connectors, but less secure than walnuts. Push-in connectors and walnuts tend to be more expensive than wire nuts. Wire nuts are still widely used in residential and light commercial applications, while push-in connectors and walnuts are gaining popularity in industrial and commercial settings where ease and speed of installation are prioritized. Alternatives to wire nuts, such as push-in connectors and walnuts, offer advantages in ease of installation, time savings, and compactness. However, the choice of connector depends on the specific application and requirements. For secure connections, wire nuts remain a reliable choice, while push-in connectors and walnuts excel in convenience and speed. When selecting wiring connectors, it's important to consider several factors to ensure a safe and reliable electrical connection. Firstly, the type of wire being used, such as solid or stranded, affects the choice of connector. Some connectors are better suited for solid wire, while others work best with stranded wire. Secondly, the gauge of the wire is crucial, as connectors are designed to accommodate specific wire sizes. Using a connector with the wrong gauge can lead to a loose connection or damage to the wires. Thirdly, the environmental conditions where the connection will be located play a significant role. For example, if the connection is exposed to moisture or corrosive substances, a waterproof or corrosion-resistant connector should be used. Fourthly, the voltage and current ratings of the connector must be appropriate for the electrical circuit. Exceeding these ratings can result in overheating or electrical failure. Fifthly, the ease of installation and maintenance should be considered, especially for large-scale projects. Push-in connectors and walnuts offer faster installation times compared to traditional wire nuts, but wire nuts are often more cost-effective and widely available. Sixthly, compliance with local electrical codes and regulations is essential. Ensure that the chosen connector is approved for the intended application and meets all applicable safety standards. Seventhly, the durability and longevity of the connector should be evaluated. High-quality connectors are designed to withstand mechanical stress, temperature fluctuations, and other environmental factors, ensuring a long-lasting and reliable connection. Eighthly, the cost of the connector should be balanced against its performance and features. While more expensive connectors may offer better performance or convenience, they may not be necessary for all applications. Ninthly, consider the availability of tools and accessories required for installation. Some connectors require specialized tools for crimping or tightening, which can add to the overall cost and complexity of the project. Tenthly, inspect the connector for any signs of damage or defects before installation. A damaged connector may not provide a secure connection and could pose a safety hazard. By carefully considering these factors, electricians and homeowners can select the appropriate wiring connectors for their specific needs, ensuring a safe, reliable, and long-lasting electrical connection. In addition to the general considerations for selecting wiring connectors, specific types of connectors have unique characteristics and applications. Firstly, wire nuts, also known as twist-on-wire connectors, are one of the most common types of connectors used in residential and commercial wiring. They consist of a plastic cap with a tapered metal insert that twists onto the exposed ends of wires, creating a secure connection. Wire nuts are available in various sizes to accommodate different wire gauges and numbers of wires. Secondly, push-in connectors, also known as stab-in connectors, offer a tool-free alternative to wire nuts. They feature spring-loaded contacts that grip the wires when they are inserted into the connector. Push-in connectors are faster to install than wire nuts and are particularly useful in applications where space is limited. Thirdly, wall nuts are a type of push-in connector specifically designed for connecting wires and wall boxes. They have a low profile and transparent housing, allowing for easy visual inspection of the connection. Wall nuts are commonly used in residential wiring for connecting switches, outlets, and lighting fixtures. Fourthly, terminal blocks provide a modular and organized way to connect multiple wires in a panel or enclosure. They consist of a series of individual terminals that can be easily added or removed as needed. Terminal blocks are available in various configurations, including screw terminals, spring clamp terminals, and insulation displacement connectors. Fifthly, butt connectors are used to join two wires end to end. They consist of a metal sleeve that is crimped onto the exposed ends of the wires, creating a secure and permanent connection. Butt connectors are commonly used in automotive and marine wiring applications. Sixthly, spade connectors, also known as fork connectors, have a fork shape that allows them to be easily attached to screw terminals. They are commonly used for connecting wires to electrical components such as switches, relays, and solenoids. Seventhly, ring connectors have a circular shape that allows them to be securely attached to screw terminals. They provide a more reliable connection than spade connectors, especially in high vibration environments. Eighthly, quick connect terminals offer a fast and convenient way to connect wires to electrical components without the need for soldering or crimping. They feature spring-loaded contacts that grip the wires when they are inserted into the terminal. Ninthly, insulation displacement connectors, also known as IDC connectors, pierce the insulation of the wires to make a connection. They are commonly used in data and telecommunications wiring applications. Tenthly, grounding connectors are used to connect grounding wires to metal enclosures or equipment. They are designed to provide a low impedance path for fault currents, protecting against electrical shock hazards. Understanding the different types of wiring connectors and their applications is essential for ensuring safe and reliable electrical connections. Always select the appropriate connector for the specific application and follow the manufacturer's instructions for installation. When working with electrical wiring, safety should always be the top priority. Firstly, always turn off the power to the circuit before working on any electrical connections. This can be done by switching off the circuit breaker or removing the fuse that supplies power to the circuit. Secondly, use appropriate personal protective equipment, such as insulated gloves and safety glasses, to protect yourself from electrical shock and other hazards. Thirdly, inspect all wiring and connectors for any signs of damage or wear before making any connections. Replace any damaged components to ensure a safe and reliable connection. Fourthly, use the correct tools for the job. Using the wrong tools can damage the wires or connectors and create a safety hazard. Fifthly, follow the manufacturer's instructions for installing wiring connectors. Incorrect installation can lead to loose connections, overheating, or electrical failure. Sixthly, make sure all connections are tight and secure. Loose connections can cause arcing, which can lead to fires. Seventhly, never overload a circuit. Overloading a circuit can cause the wires to overheat and create a fire hazard. Eighthly, keep electrical wiring away from water and other liquids. Water can conduct electricity and create a shock hazard. Ninthly, if you are not comfortable working with electrical wiring, hire a qualified electrician to do the work. Electrical work can be dangerous, and it is always best to leave it to a professional if you are not sure what you are doing. Tenthly, Regularly inspect your electrical system for any signs of problems, such as flickering lights, sparking outlets, or tripped circuit breakers. Address any problems promptly to prevent more serious issues from developing. By following these safety precautions, you can minimize the risk of electrical shock, fire, and other hazards when working with electrical wiring. Always prioritize safety and take the necessary precautions to protect yourself and others. In addition to the practical aspects of wiring, it is also important to understand the relevant electrical codes and regulations. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installations in the United States. The NEC provides detailed requirements for wiring methods, overcurrent protection, grounding, and other aspects of electrical systems. Firstly, Article 100 of the NEC defines many terms used throughout the code, including those related to wiring and connectors. Secondly, Article 110 covers general requirements for electrical installations, including requirements for workmanship, equipment labeling, and access to electrical equipment. Thirdly, Article 200 covers the use and identification of grounded conductors, such as neutral wires. Fourthly, Article 210 covers branch circuits, which are the circuits that supply power to outlets, lighting fixtures, and other electrical devices. Fifthly, Article 220 covers the calculation of branch circuit, feeder, and service loads. Sixthly, Article 250 covers grounding and bonding, which are essential for protecting against electrical shock hazards. Seventhly, Article 300 covers general requirements for wiring methods, including requirements for wiring in raceways, cables, and other enclosures. Eighthly, Article 310 covers conductors for general wiring, including requirements for conductor sizing, insulation, and ampacity. Ninthly, Article 314 covers outlet boxes, junction boxes, and pull boxes. Tenthly, Article 400 covers flexible cords and cables. In addition to the NEC, many states and local jurisdictions have their own electrical codes and regulations. These codes may be based on the NEC or may include additional requirements specific to the local area. It is important to be familiar with the applicable electrical codes and regulations before starting any electrical work. Failure to comply with these codes can result in fines, delays, or even legal action. To ensure compliance with electrical codes, it is recommended to consult with a qualified electrician or electrical inspector. These professionals can provide guidance on proper wiring methods, connector selection, and other aspects of electrical installations. They can also inspect your work to ensure that it meets all applicable code requirements. By understanding and following electrical codes and regulations, you can ensure that your electrical installations are safe, reliable, and compliant with the law. Always prioritize safety and consult with qualified professionals when in doubt. When dealing with electrical wiring and connections, it's essential to be aware of common mistakes that can compromise safety and reliability. Firstly, using the wrong size wire for the application is a common mistake. Wires that are too small can overheat and cause a fire, while wires that are too large are unnecessary and can be difficult to work with. Always consult the NEC or a qualified electrician to determine the appropriate wire size for the circuit. Secondly, overstripping the insulation from wires is another common mistake. This can expose too much bare wire, which can create a short circuit or shock hazard. Only strip enough insulation to make a secure connection. Thirdly, under-tightening or over-tightening connections is a frequent issue. Under-tightening can result in a loose connection, which can cause arcing and overheating. Over-tightening can damage the wires or connectors. Always use the proper torque when tightening connections. Fourthly, mixing aluminum and copper wires without using the proper connectors is a significant error. Aluminum and copper are dissimilar metals, and when they come into contact, they can corrode and create a poor connection. Use connectors that are specifically designed for connecting aluminum and copper wires. Fifthly, neglecting to properly ground electrical equipment is a dangerous mistake. Grounding provides a path for fault currents to flow back to the source, which helps to protect against electrical shock hazards. Always ground electrical equipment according to the NEC. Sixthly, running wires through sharp edges or unprotected holes is a common oversight. This can damage the insulation and create a short circuit or shock hazard. Use grommets or other protective devices to protect wires from sharp edges. Seventhly, using damaged or deteriorated wiring and connectors is a risky practice. Damaged wiring can create a short circuit or shock hazard, while deteriorated connectors may not provide a secure connection. Replace any damaged or deteriorated wiring and connectors. Eighthly, failing to properly support wiring is a frequent mistake. Unsupported wiring can sag and become damaged, which can create a safety hazard. Use cable ties, straps, or other supports to keep wiring securely in place. Ninthly, working on live circuits is an extremely dangerous practice. Always turn off the power to the circuit before working on any electrical connections. Tenthly, neglecting to properly label circuits and panels is a common oversight. This can make it difficult to identify circuits in the future and can create confusion during troubleshooting. Use labels to clearly identify circuits and panels. By avoiding these common mistakes, you can ensure that your electrical wiring and connections are safe, reliable, and compliant with electrical codes. Always prioritize safety and consult with qualified professionals when in doubt.